moving target 5 is solving systems of polar equations. We're not doing any ones that are difficult, though. They're all relatively simple. Okay? So if you're going to solve a system in rectangular coordinates, the rectangular equations, right? We looked at in algebra 1, algebra 2, you could graph them to see where they intersect. You could use substitution. You could use elimination. You could use matrices. There's lots of different things you could use to solve systems. Today, with the ones we're doing, all we're doing is using substitution. All right? Every single one I'm giving you says r equals something and r equals something. So they're both equal to r, then you can set them equal to each other. Okay? So all of them should be set up to start the same way. All right? I'm not trying to trick you. Then we're going to be solving. So when you solve a system, you solve for one variable, and then you go back and substitute that variable into one of the equations to get the other variable, right? So all of your answers are always coordinate. Same thing here. We're going to have coordinate answers in the form of r theta. Okay? So I've done this. The first example is pretty straightforward. The second example involves a little more effort. On the homework, there's only 3 questions. The first 2 are really straightforward. The last one involves a smidge more effort. Okay? So on the first one, you have r equals 3 minus 3 sine theta and r equals 4 minus sine theta. Since they're both equal to r, we set them equal to each other. So that means we're solving for theta in this case. That's the only variable we have left. So at the very end, we should get theta equals. So I need to get all the constants on one side and all the sine terms on the other, right? We're just combining like terms, just like we always have and always will. Yes. Yes. We're not verifying anything, so you can move stuff to side. It's all good. So we're going to subtract. You don't have to do it this way, but I'm going to subtract 4 from each side. And then I'm going to add 3 sine theta to each side. So I get -1 equals 2 sine theta. Everyone okay with those steps? So I'm trying to solve for theta, so I need to divide by 2. So I have -1/2 equals sine theta, and so we're solving for theta. So you'd have to use the inverse, which if you did in the calculator, you'd only get one answer for. That's why I told you to have a unit circle on your desk. So you're just going to look for the 2 places where sine is equal to -1/2. Should be 2 different theta values. What was one of those? No. That would be cosine, right? 210 and 330. All right, so we're almost done. Just like with any system, you solve for one variable, substitute it back into an equation to get the other variable. All right? Yes, now I'd figure r so you can write the coordinates. So you can pick whichever equation you want to pick. I don't care, but I would pick the bottom one because it seems like it's less complicated. But you can substitute into whatever one you want. So r equals 4 minus sine theta is what I'm going to use. Yes. You have to use both. These are both 2 distinct solutions, so you can just plug them both back into the equation. So we're going to have 2 different r's, we have 2 different coordinates. They intersect at 2 different places. It's not that bad. So we do the first one. R equals 4 minus the sine of 210 degrees. Well, the sine of 210 degrees is -1/2, because we just talked about that. And 4 minus -1/2 is 4 plus 1/2, which is 4.5. So when theta is 210, r is 4.5. So one of my answers is 4.5, 210. It's not that complicated. Everyone with me? Right, but you still have a point, though. Correct. So you also substitute 330 into the equation. The sine of 330 is also negative 1/2. So you get the exact same thing we just had. So yeah, your point is 4.5, but this time with 330 degrees. All right, so you have two distinct answers. This is the answer. So don't forget to go put them back into coordinate form. Don't forget to put them back in to solve for r either. Any questions about that? Can I already solve this then? Okay. All right, then the other one involves just a little more effort. A little bit, but still. So again, r equals and r equals, so they're both equal to each other. So we have 2 sine theta equals 2 cosine 2 theta. I can divide the 2 out. That's nice. No. No. Mm-mm. No. No. Yep. All right, so we have sine theta and we have cosine 2 theta. Correct. So I don't care if you actually know what it is or not, but you should at least, at the very least, if you have been paying attention at all in the past semester at any point, you should know that if it says 2 theta, then that probably means there's something that goes and we can change that. I don't care if you know what it is, but you should know that that's where this is going. Okay? So we have cosine 2 theta. Now on the red sheet, it says cosine squared theta minus sine squared theta. That does not help us because that introduces in another. We have cosine and sine, and they're both squared. Then we have this other sine, so that would just be a big hot mess. So we want a different one where there was 3 different versions in our textbook. So I put the other 2 versions at the bottom of your note sheet because I anticipated this happening. All right, so which one of those would you use?
1 minus 2 sine squared theta.
Right, you want to use the one with the sign in it because we already have a sign in the question. So I have sine theta equals 1 minus 2 sine squared theta. So, be very careful. We need to get everything on the same side. You cannot subtract sine and combine it together because we have a sine squared and a sine. So like those are not like terms. Just like x squared and x are not like terms. So, we're going to move everything to the left-hand side. So I'm going to subtract 1. And I'm going to add 2 sine squared theta. And I'm going to make it, it's going to be a quadratic equation. You'll live. It's fine. All right, so I've got 2 sine squared theta because I added that. I already had a sine theta there to begin with, and I subtracted a 1. So 2 sine squared theta plus sine theta minus 1 equals 0. If it helps you in your brain, that's the same thing as saying 2x squared plus x minus 1. Okay? So, when we have to factor this, Loy-fit, as Mr. Scott says, or whatever, you're going to get 2 binomials. All right? So, because there's a 2 in the front, that means the first 2 numbers of the coefficients in the front of the 2 parentheses have to multiply to give you 2. There's only one way to multiply to get 2. 2 and 1. All right, so I already know that one of these is going to say 2 sine theta, and the other one is going to say just 1 sine theta. Does that make sense? Now, the 2 numbers at the ends have to multiply to give you negative 1. There are only 2 numbers you can multiply to get negative 1. Negative 1 and positive 1. So it's you have to decide which one goes where. So you look at the middle term to decide. We want to get positive x. So when I do 2 times whatever this is, I want to get positive 2. And so then whenever I do sine times whatever this is, I get negative sine so that I can get a positive sign in the middle. Does that make sense?
Yeah.
Right. So you'll have a negative 1 here and a positive 1 here. That way when you FOIL, you end up with a positive sign in the middle. Now, is everyone okay with that? That's the most complicated part of this question. Once you factored it, you just say each factor equal to 0 and you solve. That's not an issue. So just the factoring part was the confusing part. All right, so we've got 2 sine theta minus 1 equals 0, and I have sine theta plus 1 equals 0, and we need to solve both of those. So for the first one, we add 1, divide by 2, so sine theta equals 1/2. On the second one, we subtract 1, so sine theta equals -1. You use your unit circle. Where is sine theta 1/2 on the unit circle? 30 and 150. And where is sine -1? One place. 270. All right. Thank you, Brandon. Great. All right, we have 2 equations we can substitute these back into. Obviously, the first one is less complicated. Again, you can use whichever you want to, but obviously the first one's less complicated. So r equals 2 sine theta. So I'm going to have, what happens to r when you give sine of 30? Well, sine of 30 was 1/2. We just talked about this. So 2 times 1/2 is 1. A point at 130 degrees. You have 2 times the sine of 150. Sine of 150 is also 1/2, and 2 times 1/2 is also 1. So you have 150 degrees. Sine of 270 is -1. So 2 times -1 is -2. So your last point is at -2, 270 degrees. Well, the book would like you for you to graph these first and then show that they intersect by doing the math. I'm taking out the graphing part, so you should be thinking.
Thank you.
Okay, so, all right.